Hello friends, सबको नमस्ते. So today in this video we will create a object detection telegram bot, and for that we use multiple models. You can see we are using 6 model. So before explaining this code one line by line, let me show you how our telegram bot working. Okay, so go to the browser, open a telegram bot, open this and type start command. Wait for the second. See this buttons, you can say for the selection of the model. I will select this one. Okay, let me select image of let me select this one. Wait for the seconds. See, it will give me the object detected image with the, you can see with the detections, and it also give me the counts. Its counting will be 3, you can see that, and also give the information that which model we are using right now. Okay, so this way our model telegram board will work. So now let me comment the whole code so that I can explain you that which function come first, so that you will not get confused for while making this telegram board, that which step is first and which step is come to the last. Okay, so the first step in this of creating a telegram board is to generate this token ID. So go to your browser, type it here, board father, and after getting you will have to use this. Now just here type help command. You will get the step interface. Go to new board, type your board name. I will use image, not image, just object detection. Object detection. Okay, then enter it. Then you have to give your user ID. I'm keeping the same, but make sure the last 3 character will be both. It's already taken, so let me give you object detection image. Type any word, last 3 character will be both. Press enter. It will generate a token ID, and this is a token ID which connect your Python file with your with the telegram bot. Copy it and just replace here. Okay, paste it here. This is the first step. Now our second step is to use of this token ID and connect the Python file with your telegram bot. For that we use application package, then the builder function, then pass a token ID, and build function. Then this way we'll connect the Python file with the telegram bot, and this app variable will act as a reference of your telegram bot. Now to create the start function, we will use app handler, then the command handler package. Then whenever a user types /start, it will activate this start function, and here start is basically the function name. So the compiler will come to this start function. Okay, see here data. See, this is our models. Let me explain this also. We are using 6 type of models. So on first we using fruits object detections. We have classes like this, and each class has its own colors, and the Python weight file name will be this, and weight file name is stored in this folder. This way you can see that. Okay, this is a weights file name, and second one is a beer object detection, then pothole, then platelets, RBC and WC, then pistol, then hat and helmet and person. This is a model which have a classes head, helmet and person, but most of the images in this will be most of the images that particular model train on is on helmet. So you can say that particular particularly this type of this model is used for helmet object detection. Okay, so the compiler will went here. We are passing two parameters, update and contest. Or you can see that I have passed the context parameter, but I have not used that per contest parameter in an entire function uh, because you can see that passing the parameter update and context is a default structure by the Telegram bot. Okay, so that's why I have to pass update and contest in the parameter has an initialization in a function. Either I will use it or not, it's up to me, but you have to pass it as I pass it as a parameter because of the default structure of the Telegram bot. Now let me explain you the meaning of this call contest. What is the use of this contest? Contest is basically a toolbox which have a different tools like that. You can set a reminder in your Telegram bot, and the second thing that you can uh, store the specific chat of your Telegram bot. Now, what is happening here? For that, let me explain you this whole code, this whole thing with the help of the code. So, let me copy it. Let me go to my help code, help Jupyter file. I will explain you this whole thing. Don't worry. Okay, this is code which is used. Move up. I want to move it up. So now you can see that what is happening the input in a start function. First we will initialize the buttons list inside it. Then we iterate over the data. You can see that when I for I, basically this I is actually the key here, 1 2 and 3. You can see that 1 2 3 and 4 when I print this I with the model classes. And you can see that model classes is like this: bg, apple and class names. So when first went to class name of each model id. You can see this 6 1 and 2, these are the model id, and just inside the class names you have to separate them with the comma. This way I generate the model classes. Now this is the initialization of the button. For that, we use inline keyboard button, and this is a text which I want to display on the button, and this is the data which I want to send to the bot whenever a user click on the button. Okay, so after initialization, I have to append it into the buttons list which I have generated here. Okay, so when I print this button, you can see that you can see this line. It is a list of all the buttons till here. Now this if you pass this buttons and in the reply markup, then it will not display it, it will throw the error. Okay, because it is not in a proper structure that a Telegram bot will support. To make that to make it supportable with a Telegram bot, we will wrap those whole buttons in one thing, and it's for that we use inline keyboard markup. It will wrap all button in one, and we will get this keyword, and we can use this. You can see that this is the inline keyboard markup, which wrap whole buttons in one, and you can easily display these buttons uh, above below the masses whenever the user type start command. You can see that whenever the user type start command, this masses first display, and to display whole button below this masses, we will use this reply markup here. And one more thing, see, let me uncomment this. Whenever the user click on a start button, whenever user click on this particular button, no, buttons, this let me show you. Might be one. Yeah. Whenever user click on these buttons, a query is generated, and that query is sent to the Telegram bot. And when the Telegram bot see that a query is generated, it will activate this callback query handler, and this callback query handler basically automatically activate this button handler function. And this button handler function get activated. You can see that we will have a I have to pass update context. But now this time I have to use this context because I have to save that model ID, which is useful which is useful to get other details like class name, color sample, and weight name. We have to save that model ID. Okay. So what is happening here? Let me save whole things so that I can explain you easily what is happening in this particular function. Before that, not no. Let me first explain you that one function so that you will not get confused. So let me run it. Go to your browser, go to Telegram board. This time we have changed the token ID. So click on this. Start. Start. It will display the message. Wait for it. You can see that these are the buttons, and whenever I will click, suppose I click on this button, beer button, a query is generated, and you can see that, see, this function get activated, this button handler. So update dot callback dot query, what is this? This is the information related to that button, whole information related to that button. See the informations, data from user, which user, ID, boat ID, these are the buttons, this all things. This whole information related to that button will display, will be stored in this update dot callback query. But what is the information which we want? We are passing callback data string ID, means the model ID we are passing here. We want this data, and this data is stored in this data attribute. So for getting this model ID, just use query.data. You can see that here we are passing that I model ID in a string. So but for fetching the whole details, we want that in int format, so we convert that into int. After that, we are storing that model ID in this selected model dictionary. See, context dot user data selected model, this is a dictionary where we are storing model ID. So this is a use of this context. Okay, after using this, we can easily get the weight name, just data model ID weight name, you will get the model name, and just we can display it. So this is when a user click on this button, this is a query. So to display the query, we will use query dot added message dot text. This message will display on query whenever user click on this particular button. So let me close it. Now we will create this help command. Whenever user click on the type the help command, it will show that what is which command particular board using. So it will display this. I already told you that why we are passing update and context. Okay, default structure of Telegram board, it will display this message whenever user type help command. Now main thing, this is a function which handle the photo whenever user click on whenever the user send the photo in a Telegram board. So to handle it, we will use message handler package, and filter photo means only at that time you have to activate this handle photo whenever the user send a photo in a Telegram board. So this function get activated. Okay, whenever this function get activated, you can see that if suppose in a context or user data it is none, not in this, it means the user have not selected the model, and it's sending the photo in a Telegram board. And this is the error because it will not give the board will not give the object detected image because the model is not selected. So this error message will get displayed. Okay, now whenever the user select the model, I can easily get the model ID because we have stored that in a user data dictionary. Okay, so I can get a model ID. After getting the model ID, I can easily make the whole data related to that model. Suppose if the model ID is 6, so the whole information related to that model ID, I can store that in this variable model data. After storing this store whole data in model data, I can easily get their weight name. Okay, I'm printing it, but right now it's not necessary to print them. Okay, So whenever the user send the photo, first we fetch the model ID, then the from model ID we fetch the weight name. After fetching the weight name, this will happen. This line basically, you can, one thing that I want to tell you, that whenever you send a photo in a Telegram bot, Telegram basically generate multiple images of different resolution. So this line update.message dot photo and -1 basically select the highest resolution photo among them, and this dot get file basically fetch the file from the server. After fetching the files, we will download the file as a byte. Okay, after downloading the file in the bytes, I have to convert that into into a file format, or store that particular file into RAM. So that for that we use bytes IO. After using it, since the image is in a bytes, so I have to decode it. For that I have used cb to decode. Okay, after decoding it, I have converted into the PIL format, or you can see that here I am converting that image into a NumPy format, and then I have converted that into the image PIL format. After converting that in PIL format, I passing it into the I am passing this model data and image to this object detection image function. So this function get activated. And one more thing I want to tell you, that you can see that the, among the six models, we these models use two different type of algorithms for object detection. We have faster R-CNN as an object detection algorithm, and one is SSD. Okay, you can see that these two are faster R-CNN, these two are SSD. This is faster R-CNN, this is SSD. Okay, so this way, and you can say that among the six, three are using faster R-CNN model, and other three are using SSD model. So according to that only, we have to select this function, detection SSD and detection faster R-CNN. Okay, so the compiler will went to this function. From here it will went to this function. So here it will decide that either we have to use detection SSD or detection faster CNN. So it will went to model data, model type SSD. If it SSD, it will went to detection SSD function, otherwise detection faster RCN. So but in both functions, let me wrap them whole. In both functions we are passing only, we are passing image, model data class names, model data and model data weights name. In whole thing we are passing at one go. Okay, suppose let me explain you both. See, models are one more thing that I want to explain you. Suppose, let me take one example, detection. Suppose this is a detection ssd model which the user select. So it will went to here. From where this function come, models folder. In folder, from where it's coming from here. Okay, in its C it's coming from detection ssd coming from detection folder, and here it has a ssd object detection python file, and inside the ssd object detection python file it has a detection ssd function. So go to detection folder ssd and you get this detection ssd function. So when it's we are passing image, class name, color sample, and weight. Here weights is basically the weight name. Okay, see here, this is the weights name. Okay, after getting it, first we have to create the model. For creating the model, we have to pass the number of classes and the size which the model train on. 640 is the size, so the compiler went to this function. So for that, what is how the model is created? Let me explain you this by this help code. So first thing is SSD model. So let me unprint it. Let me uncomment. Sorry, not unprint, uncomment. Okay. Now let me run it so that I can explain you briefly. It's taking time. See that. You can see that this basically the structure of the SSD model is that. Let me open my browser. Now let me type SSD BGG16 architecture. Now images. You can see that in each images, the head of the this head basically this head is connected to the sequential last layers. You can see, suppose this is a sequential layers, last layer is connected to the this head. This is a sequential, its last layer is connected to this head. This is a sequential, this last layer is connected to this head. Anyway, sequential is that in one sequential multiple layers will be there. Okay, this way it means the head is connected to the last layer of each sequential. Okay, so you can see that. See, this is a classification hat and regression hat. Okay, this this is the head of the SSD BGA16 model. It's at a two head classification head, and you can see that 512, 1024, 512, 256 from where it's coming. You can see that for the connection of one layer with a different layer. Uh, so we want out channel of the previous layer for the connection. Mind my words, out channel of the previous layer for the connection. Okay, so and this out channel of the previous layer act as a in channel for the coming layer. Okay, so 512 1024 512 is a in channels. So how it's getting, you can see that this is a sequential one, and its sequential one, you can see that last layer out channel is 512. So here it is 512. Now next is 1024. So this is the last layer, this is sequential, second sequential, and its last layer is one, and this one last layer is this one, and its out channel is 124. And it's this is a third sequential, last layers out channel is 512, 256 and 256. Here 256 two time, because here it is 2 into sequential, that's why 256. So this way it's getting the in channel 512, 1024, 512, 256 and 256 into 256. Now from where this 364 is coming, you can see that we are using Coco V1 dataset preteen, and in Coco dataset we have 91 classes. Okay, now you can see this in channel, this is in channel, and number of anchor boxes. You can see that when an image is converted to a grid, and each grid cell has its own number of anchor boxes to generate for detect the object detection of different scales. So these are the values of these each layer anchor number of anchor boxes. So if suppose four anchor boxes for this layer, and we have 91 classes, so when you multiply 91 with 4, you will get 364. Now second layer we have six anchor boxes, so when you multiply 6 by 91, you can get this 546. Now this third layer, again 6, again 4. This way you calculate the out channel of each layer. Now this way come to this thing, in channel is same 500 to, you can know how it's coming. See how it's coming. 16 basically, you can see that bounding boxes value have four values, four coordinates only. Okay, uh, you can see that sometimes it is x1 y1 x2 by2, or sometimes you can see x min y min x max y max. This way means four coordinates will be there. So first layer have four anchor boxes, means 4 into 4 16. Why we are multiplying only with 4? Because bounding box have only four coordinates. 6 into 4 24. This way it's calculated, but it is according to 91 classes. This whole head is related to only related to 91 classes, but we want to change it according to our number of classes. So you can uh, you can see that first we have used this utils package dot retrieve dot out channel. We have retrieved the out channel, then we have retrieved the anchor boxes using this line. And after using this line, just we have used the SSD classification head and passed the in channel, number of anchor boxes and number of classes. So it's generate the model according to our number of classes. Okay, so let me comment this whole thing. And right now I'm just passing three number of classes at a time, and this is 640 size. So now let me, when I print model now, you can see that now this change according to our number of classes. I had passed 3 as a number of classes. So here 3 when you multiply with 4 according to anchor boxes, it will display me 3 into 3 4 to 12, and 18 is you can see that second layer have 6 anchor boxes. So 6 into 4 6 into 3 6 3 18. Okay, this way it's calculated. Okay, so I had explained you this model. Now let me explain you this model also, because it's related to the same thing. This is a uh, faster R-CNN model, so let me explain you this also. Okay, so here we are using torch neural model, faster R-CNN, resistance 50 as a backbone and FPN, and the weight file we are using Coco V1. So you can see that last layer, or you can say its head. Basically, this is a head. You can see its Coco dataset is trained on 91 classes. Okay, so we have to change it according to our number of classes. So you can see that, go to the model, go to the ROI head, go to the ROI head, go to the box predictor, go to the class score, go to the in feature, because we want in feature, because we have to change this layer according to number of classes. And you can know that the main thing is that in general our channel is depend of on our number of classes. So you can see that, go to the for getting the in feature, go to the model, go to the arrow head, go to the box predictor, go to the class score, and go and fetch the in channel. And after that, change the model ROI head according to our box, according to our classification, according to the number of classes. Okay, so this way we have changed the last layer. Now let me print this one. So you can see this last layer is changed according to our number of classes. No, this is 12 because we have box regression box have 4 coordinates. When you multiply by 3, because we have 3 number classes, then you get 312 value. So you can see last layer is out channel will be 3, because I am passing 3 has a number of classes. Okay, so this is, yeah. Let me close this, save. Let me close this also, this also, and I already explained this thing. So compiler will enter here. Okay, it will return the model. Then it's come to this. Now this line, first we have to fetch the weight. First we have to generate the weight path. For that we have used os.path.join, os path direct name, weights and weights name. And after that I am loading that weights file, and my application will be CPU. We already know that, because right now I'm not using GPU. Right now I'm using a CPU, that's why. Now then the model.eval, because now the model is in evaluation mode, not in a training mode. Then just convert the image into tensor. Now apply the transformation, then unsqueeze, because it add a batch dimension in the image, because during training we pass the images in a batch format at same and during testing time it is impossible, it is important to get to pass the image for prediction in a batch format. Now which torch no grade means no gradient will be there, no updation will perform, just pass the image. And 0 basically get the image prediction, because we are passing only one image, so 0 will be there. Now here this prediction basically is in dictionary format. Okay, and also all the values is also in a tensor format. So see that, to get the bounding boxes values, go to prediction, go to the boxes key as a key. Now what is use of CPU? CPUs, I'm using here CPU because suppose I will use GPU, if or I can say that when you use the same code and you will use GPU at that time, so you want to flow the whole data from GPU to CPU. At that time, you can use dot CPU, and dot NumPy is because you can see that the prediction made by the model is in a tensor format. So I have to convert that whole thing into NumPy. So that's why I'm using NumPy, and I'm applying this whole thing with boxes, label, and score both. Now filter label, counter, images. See these two things. What is happening in this two line? I will explain you with the help of example. So come to my helping code. See, suppose these are the labels. Predicted label. Okay, predicted label example, and these are the scores related to that predicted label. And we have class names: apple, banana, and orange. Let. So here what is happening? First for loop here till here. First for loop means looping two labels and zero scores at one time, at the same time. Then if score is greater than if score is greater than 0.8 means 80%, then make a list, then print that labels in this and generate the list of that. So it will generate me list 1 2 3 1. See, 1 because the score is 91, 2 no because 2 also 88. Here 1 45, it will not display me. 3 92, display here. 2 69, not 60 60, no. Then 1 so 99. So this way I get the result filter labels. Now when I will use this counter package, it will generate the dictionary with each label counts. You can see counts of number 1 will be 2, counts of number 2 will be 1, counts of number 3 will be 1. This way I get the count of each labels. Okay, this three line I will explain you later when I will come to that lines. So this way I get the counter of each label. After I get the counter, then convert that image into NumPy array. Then drawing the bounding boxes on that particular image, just pass the images, then boxes, labels, code, class name, class colors. This way the compiler went to this function. Now what is happening here? See, images with boxes. First it will create the copy of the image, then we have to zip we so but at same time only we have to iterate over boxes, label, and scores. So for that we use zip, so that we can easily iterate boxes, label, and score at one time. And if a score is greater than score threshold, and score threshold is 0.8, if so, only that time, at that time only, or that at that particular condition only, we can iterate to this whole code. Otherwise it will skip. So it will first give me xmin, ymin, and xmax values. Xmin and ymin is basically a uh, top left coordinates, and xmax, ymin is basically the bottom right coordinate of the bounding box. And what is the use of this map and int and box? Because these values might be in a float, I want to convert that into the int. So that's why I have used this map, int, and box. So it's convert the box values into the into int format. You can see that's variable int. Okay, now after that I have to use the color. So color sample, you can see that see, it is a list of the colors of each related to each class. But I want for getting the color for each class, I will label divide by length color sample, so that I can easily get the color from the color sample list for particular class name. After getting it, I want to draw the bounding box on our image. For that, just give the image, then the starting coordinates and our last coordinates. The starting coordinate will be the top left coordinates, and this x y top bottom right coordinates. Then the color, then the thickness. Okay. Now you can easily see. Let me show you one image. See this image. Okay. You can easily see that bounding box or porthole is displayed just above the bounding box. So how we are displaying that? See, first we get the text, means the class name which we want to display on above the bounding box. For that we just use class name and label. We can easily get the text. Now first we will get the text size which we want to display. Okay, for that just pass the text, and the font we want is this 0.5. You can see that a font 0.5 will be the font scale, and 2 will be the thickness. Now after getting it, just use this text width and text height. You will get the text size which you want to display above the bounding box. Now what is the use of this adjust text position? To prevent out of the bound. What is the use of this? Means whenever we print x by mean, one thing I want to explain you that explain not I want to tell you that for the image by coordinate 0 0 value start from the top left coordinate of the bounding box. So suppose if the y mean value will be near to the bound, near to the is too low, that it is near to the bound of the bound of the image. Or for example, if suppose this is an image and y value is near to here, okay, near to here means out of the bound of the image. So for that, when we will minus the text height, minus the text height. Suppose this is the starting value of the y min. When I will minus the text size, means this size, this text size, it will go above. Okay. Now if suppose I minus the I minus the text height and it go beyond the image height, so it will display not it will look very bad on an image. And if suppose I minus 5 will be the what is the use of this minus 5? Basically minus 5 is that thing that see y min will be here, minus the text come to here, minus for 5 means go to here, and this minus 5 value will act as a padding. Okay. And comma 0 because it will select maximum value among this. Suppose I use this like y mean minus text and minus 5, and the value go beyond the bound of the image, so it will its value will be negative and it will throw the error, or if it doesn't throw the error, the bounding or the label will not look good on a bounding box. So last value will be 0. After that we have to for background we have to create the rectangle which is filled. Okay. So for that we just pass the image. Starting coordinate will be x min and y min. I already told you that my min minus text, my min text means maximum value among this, and minus 5 just add a minus 5 basically for this, for going above the bounding box. Okay. Now same last coordinate will be bottom right of the bounding box. So this will be x min plus the text width, uh, x min plus the text width. This is a text width. So to get this coordinate, we have to x min plus the width of the text. Okay, plus 10 for extra padding, and just keep the y min. The color text, just for the text we have to pass the starting coordinate. So this is the starting coordinate, image, text, font size 0.5, scale, color, thickness 94. This way we put the text on the rectangle, or you can see above the bounding box. Now after that we get the image with bounding box, so the compiler went here and it return images of the boxes and the counter itself. Now the compiler will come to here, it will get the resulted image. Okay. Okay. Now we have to convert that image into the NumPy array. Then we have to use encode with compress that image into the JPG format. See that Here the decodation. Now we have to encode it to display that image into Telegram board. Then I have to use this byte ID IO because I want to make that particular file make up file object. Okay, then we have to pass the image and the counter. The compiler will went to here, image and a counter. Now what is happening here? See this. Label counter is 0. Let me print this. Okay, so I in range starting value will be 1 because at 0 index you can see that at each class name 0 index value is for the and background, and we do not want to display that particular do not want to count that particular class. Okay, so starting value will be 1 and its last value length of the class names. Skipping background, you can easily see this. Label counts, you can see what to display this means. For to display the class name with the counter, you can just use class name I and counter I, because you can see that counter I basically the dictionary with each class name counts name. Okay, so this is happening here. This is happening here. It's can generate the label count. Then we have to change the pointer. After changing the pointer, we will we will have to display the masses. For display the masses, just display the photo, but right this time we have to display the photo, so that's why we are using updated masses reply photo. And the caption is basically what you want to show below the image. We want to show model used and the detected counts. Label count will display as marked down this way. We have created our Telegram bot. Okay, I have shown you what is faster R-CNN, but for the SSD is same. The difference is just a create model, but I have already explained you this whole thing. Okay, this is faster R-CNN. Same whole thing is same, just a create model function is difference. So let me run this so that I can show you the result, how it's working. Let me unzoom it. Start command. So we will get to this. Let me select this. Now let me select one image. Wait for the seconds. The processing of generating the object bounding box is taking time. You can see here this way it's display the bounding box, and you can also see the counts. Apple is 8. Now let me select a different model. Just start. This time beer. Now let me select one image. Okay, this way. Now again I want to select different model. Portal. Let me select this one. See, it's working. Portal 3. Now let me select again different pistol. Okay, it's working. Now next model. Okay, so this way our whole code is working, or our whole board is working. Okay, so let me show you the prediction of this photo. Okay, helmet one. So this way our whole boat is working. Okay, I had explained you each and everything here. One more thing that I want to explain: this run pulling is basically the important line that if you want to respond from your board, that when you type start command, help command, it will respond to that command. Or whenever you send the image to telegram mode to this to make the board responsive, you have to use this app to run pulling. If I will comment it and run this whole code, the telegram board will not respond to any message. Okay, so this is the important line. And one more thing, that I have used await and async to make the whole board asynchronous, means it will handle multiple things at one time. Okay, that's why I use async and await. So I explain you each and everything here, each line thoroughly. So please like, share, and subscribe. Thanks to all.